My name is Azadeh Mohase. I've been working in the field of zooarchaeology since 2003 when I started my master's. I obtained my PhD degree from the Sorbonne University in Paris in 2012. I've been working on several zooarchaeological projects, namely studying the faunal remains from archaeological sites, stable isotope analysis, and geometric morphometrics. Statistical analyses are an essential part of my work, and honestly, I was not so good at it at first. Over the years, I've used a variety of different methods and types of software, and in the end, I found that the R programming language was the best choice for several reasons. R is a programming language primarily used for data manipulation and performing statistical analysis. It is free and available under an open source license. It is available for different kinds of operating systems such as Windows, Mac, and Linux. There are a vast variety of packages written in R for a variety of different simple or specialized purposes. It is dominant among programming languages for developing statistical tools. Methods for data visualization and representation are highly developed in R. There is an engaged community for R users who support new users. And in my opinion, one of the most important advantages of R is that anybody can learn and use it even with no prior programming background. I have to tell you that I'm not a statistician. Actually, I began learning R because I didn't want to be dependent to other people to understand which analysis should I choose for a given set of data, which statistical analysis should I perform to test my data, and which software works better for a given analysis. I started learning R by participating in R courses and workshops. I tried to apply what I learned in these courses in my studies. To solve my problems, I used several tutorials, I wrote many emails to the experts, I read several books, and now all you will learn in this course is the fruit of the years of research that was initially started with the aim to be able to perform my own analysis independently. I am sure that I was not the only one who encountered such problems in our work field, and I thought, why not share all this valuable knowledge with my colleagues in order to facilitate and shorten their way to learning statistics and performing the analysis with a wonderful tool that is not only a user-friendly interface, but a powerful programming language that lets you go deep into it. After this course, which is an introduction to using R and making analysis for general zooarchaeology, you will be able to use R for any other purposes. People all around the world have shared their knowledge for performing analysis on a wide variety of specialties in forms of packages, and you can use them easily and for free. As I personally did not have a programming background when I began using R, I understand that some of you may be apprehensive about learning how to program. So I've tried to keep this course relatively basic and will not go deep into complex programming. I can also reassure you that even researchers who have been working for years only with very simple statistical tools would be able to switch to R in a very short period of time and consequently enjoy statistical analysis much more than before. In addition, as R is an open source project, there are many articles, blogs, forums, and tutorials available on the internet that can help you find the answers to specific questions. During this course, we will work on the basics of R, how to import data into R, how and when to use statistical tests of significance, and how to perform statistical analysis in zooarchaeology. For each step, I've prepared several examples with model datasets. This course includes 10 sessions composed of almost 5 hours downloadable videos, R scripts, and real datasets. To make sure that this course is beneficial for you, I want to briefly go over the course structure. we try to order it in a way that is most useful if you are a complete beginner in R programming language. In the first session, we will focus on a brief introduction to R and RStudio, the history of R, how to install R and RStudio, and the R and RStudio interface. In session 2, we will talk about the variables, data types, and data structures in R, and we will discuss some basic functions. In session 3, we will talk about how to import data from CSV, text, and Excel formats into R. Also, we will learn how to install packages. In session 4, we will talk about the basic statistical operations that we generally use for zooarchaeological data analysis. Also, we will learn about the categorical and quantitative data. In session 5, we will assess what statistical tests are and how to choose the appropriate type of statistical test for our dataset. In session 6, we will learn how to draw bar plots for categorical data and histograms for quantitative data. In session 7, we will learn how to draw box plots for univariate and scatter plots for bivariate analysis. In session 8, we will learn about the principal component analysis and linear discriminant analysis and how to perform them in R. In session 9, we will assess the correspondence analysis and hierarchical clustering. And finally, in session 10, we will learn about how to perform the log size index as well as the survivorship curves and mortality profiles based on the dental eruption and bone fusion. As a zooarchaeologist, I would like to help my colleagues to have access to a powerful and user-friendly interface to perform their statistical analysis. I hope that this course will be helpful and will provide an accessible introduction to the R programming language.